The next concept that we're talking about in Unit 4 is X and Y intercepts. So what I want to do is just on a blank sheet of paper, open it up where you have that blank notebook paper. So I want you to draw a graph. That's not one that I want you to draw. I want you to draw a graph. Stand this way. I want you to look. All right, so here's a graph, ugly though it is. That's my X and that's my Y axis. Now, I want you to think about if I put points on here. So here's my little, okay, here are the points on the X that are crossing the X axis. If I labeled this point, this would be 1, 2, 3, 4, 5, 6, negative 6, 0. This point would be negative 4, 0. This point would be negative 2, 0. This point would be 1, 0, 3, 0, and 5, 0. I want you to look at all these points, and I want you to think about what they all have in common. Well, one, they are all crossing my x-axis, okay? So therefore, they are called my x-intercepts. And in Unit 3, we talked about x-intercepts. We called them the roots, the solutions, and they had that list of language there. So these are all x-intercepts. What do all of these x-intercepts have in common? Your x-intercepts all have 0 value for y. So no matter what, all x-intercepts, your value for y is always 0. Always. Always. Now, I want you to look at these points. And let's label them. 1, 2, 3, 4, 5. So 0, 5, 0, 2, 0, negative 2, 0, negative 5. These are my y-intercepts. So my y-intercepts all cross the y-axis, but all have x value of 0. Okay, that's very, very important. So this is graphically what x and y intercepts look like. And we're also going to look like, what do they look like algebraically? But I want you to have this visual in your journal, okay? So that you can see all y-intercepts have an x value of 0. All x-intercepts have a y value of 0. All right, so let me get out of there, and then let's go to our journal that starts the x and y intercepts. All right, so here we go. The point at which the line intercepts the x-axis is called the x-intercept. Okay, so that we kind of touched on. The point at which the line intersects the y-axis is called the y-intercept. So if I want you to identify the x and y intercepts, you could say it's 1, 2, 3, 4, 5, 6, 7, 8. 0 is your x-intercept, and your y-intercept is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that's your x-intercept and your y-intercept. That's when you look at it graphically. Algebraically is different. When you think of algebra, you want to think equations. And we already know how to solve equations. That was Unit 2. So graphically, we look at a graph. Algebraically, now we have a formula. We have an equal sign. We got some work to do. So to find the x-intercept of an equation, well, then can I just plug in 0 for my y value and solve? Doesn't that make sense? If the x-intercept always have a y value of 0, let's just plug in 0 and solve. To find the y-intercept, let's plug in 0 for x and solve for y. All right, so let's look at an example for that. My example to find the x and y intercept of y equals 3x plus 6. So if I want to find the x-intercept, remember my y value is 0. So now I can solve for x. And x equals negative 2. So when x is negative 2, my y value is 0. Right? When I want to find my y-intercept, I'm going to plug in a 0 for x and solve for y. 0 plus 6 is 0. So when x is 0, y is 6. And now it looks like just what it did on our paper. My x-intercept is -2, my y value is 0. My y-intercept is 6, and therefore my x value is 0. So all we're doing then is we're really just covering up values. We're covering them up. So if I want to solve for x, my x-intercept, I know that my y value is going to be 0. And now I just solve for x. X equals 5. So my x-intercept is 5. And if I want to find my y-intercept, I plug in 0 for x, and 0 here is just 0, 0 plus 5, and so y equals 5. So I want you to do a couple examples on your own, and I'm going to give you the answers to those. Let's do some odds. So my x-intercept, y value is going to be 0. So now I'm going to solve for x. I subtract 2, and I get -2 equals -4/3 x. How do you get x by itself? You multiply by the multiplicative inverse, which is multiplying by a -3/4 and a -3/4. So x equals a negative times a negative is positive. Cross reduce, which you should be able to do, 1 and 2, and it's 3/2. So x is 3/2. That's my x-intercept. My y-intercept, remember my x value is 0, so when you plug in a 0 for x, that just makes this term 0, and 0 plus 2 is 2. Okay, so 0 plus 2 is 2. All right, let's look at number 5. If I want to find my x-intercept, I know my y value is 0, so 0 times -2 is just gone, really. And then divide both sides by 3, and x equals 4. So my x-intercept is 4. Now, if I want to find my y value, I know my x is 0, so I can just cover that up, because that's 0. And then -2y equals 12. Divide both sides by -2, and y equals -6. So my y-intercept is -6. Okay, so hopefully y'all are getting the feel of what that looks like. Now, when I graph them, find the x and y intercepts of each graph equation, and then graph it using intercepts. So now there's a different way to graph. You can always do y equals mx plus b, because that you can, y equals mx plus b, find the beginning point, do the slope, voila. But when they're in standard form like this, sometimes it's easier to just graph the intercepts. So I know that my x-intercept, my y value is 0, so when y is 0, x is going to be 3. So I can graph the point 3, 0. And my y-intercept, when x is 0, y is 3. And now I can graph those using a straight edge and going all the way through to have arrows on both ends, right? Let's look at number 9. To find my x-intercept, y is 0. So when y is 0, my x value divided by 9 is going to be 5. So 1, 2, 3, 4, 5, 0. That's my x-intercept. And then to find my y-intercept, my x value is 0. Divide both sides by -15. And I get when x is 0, y is -3. And then I graph my line all the way through, arrows on both ends. Okay? So if you have questions, come see.